Hello guys, how is it going? In the last video, we talked about the concept of pressure, right? We saw that pressure is nothing but force acting per unit area on any surface. Now, we also took numerous real-life examples that explained the concept better. But in all those examples, we majorly took solid objects as our references. We didn't deal with any liquids or gases. So, the obvious question here is, are liquids and gases also capable of exerting pressure? Well, turns out the answer to that question is yes, they are. So in this video, we'll particularly focus on the pressure applied by the liquids. Liquids have an amazing property, and I'm sure you know about it. Liquids, when poured into a container, take the shape of that container. Consider water for instance. If I pour water into a cylindrical tumbler, it will take the shape of its container and transform itself into a cylindrical tower of water. Similarly, if I pour water into a conical flask, it will take the shape of the conical flask. And if I pour water into a round bottom flask, it will take the shape of round bottom flask. Now, as you can see, the three containers have water up to certain levels. Now, if I poke a hole somewhere towards the top where the water is not touching a container, do you think water would flow out of that hole? Well, certainly not, right? We know that water doesn't jump like monkeys. Right? Our intuition tells that water can't flow out of that hole. So if water can't flow out of that hole, does it mean that water is not applying any pressure at that point of the container? Yes. So the same is true for the other containers as well, by the way, which is the conical flask and the round bottom flask. So what we understand from there is that liquids don't apply any pressure on the container walls above their own maximum level. However, if I poke a hole somewhere towards the bottom, you know what will happen, right? Water would simply flow out of that hole. Now, this happens because water is certainly applying some pressure at that point or at that height in the container. Now, to understand it better, imagine water as an angry mob of people waiting outside a cinema hall. As long as the hall's door is closed, the mob keeps accumulating outside and applies pressure on the door, trying to break it open. But if the door is suddenly opened from the inside, the mob of people fall in the hall chins first. Water is just like that. As long as the container is present around water, it keeps applying a pressure on the walls, in a way trying to break it open. But suddenly, if you poke a hole, the water simply flows out like the mob of people falling inside the hall. So by now we understand that wherever a liquid, which in our case is water, touches the container, it applies a pressure. But the next question is this applied pressure uniform throughout the container? Or in other words, is the pressure same at the topmost point and the bottommost point? Or is it different? Well, let's check that out with this activity. Take a plastic bottle filled with water. Poke a hole towards the top of the bottle and poke another hole towards the bottom. What can you say about the flow of water through the two holes? Well, clearly, the water flows much more rapidly through the bottom hole than the top hole. This means that the pressure applied by water at the bottom is higher than the pressure applied by water at the top. Great! Now take a new bottle filled with water again. This time, poke two holes at the same height, but opposite to each other. What do you see this time? Well, obviously, water flows at the same speed or at the same intensity from both the holes. So what does this tell us? This tells us that water or liquids in general apply the same pressure at the same height. So, from the activity we can conclude that as we move upwards, the pressure applied by the liquid on the container's walls decreases. This means that pressure applied is lowest at the highest point of the liquid column, and pressure applied by the liquid is highest at the bottommost point of the liquid column. Apart from that, we also saw that a liquid applies equal pressure at the same height. Now, what's also interesting about these observations is that they are not just applicable to a cylindrical tumbler, but also to a conical flask, a round bottom flask, or absolutely any irregularly shaped container. Yes, liquids in any of these containers follow the exact same principle, which is low pressure at a higher height of the liquid column and a high pressure at a lower height of the liquid column. So till now, we talked about pressure applied by liquids on the side walls of a container. But what about the bottom surface of the container? How does the height of a liquid column relate to the pressure acting at the bottom surface? For instance, consider these two tumblers over here. You can see that the first tumbler has a taller water column than the second. In which case do you think more pressure is acting at the bottom? Take a moment and think about it. So, could you come up with an answer? I'm sure you did. Let's verify it by doing another activity. So, first of all, let's fix two balloons on the mouths of each tumbler. Now let's turn the tumblers upside down. What do you see? Clearly, the balloon tied to the first tumbler with a higher liquid column inflates more than the second tumbler with a lower liquid column. This means that the pressure acting on the base is high when the liquid column is tall, and the pressure acting at the bottom is low when the liquid column is short. So after that activity, guys, I'm sure there is no doubt left anymore. A taller liquid column applies more pressure at the bottom as compared to a shorter liquid column. And on that note, let's end our video today. I hope you had a good time learning about the concept of liquid pressure. In the next video, we'll talk about gases, and we'll see if they apply pressure on the container's walls just like liquids or not. Apart from that, we'll also take a look at atmosphere and its pressure on us and the objects around us. For now, let's summarize what we learned so far. A liquid always takes the shape of its container. A liquid applies pressure everywhere it touches the container. A liquid applies more pressure on the container's walls towards the bottom and less pressure on the container's walls towards the top. A liquid applies equal pressure at the same height on the container's walls.